Assalamu alaikum wa rahmatullahi wa barakatuh. This is Ahmed Higazi from SECAD Solutions. Inshallah, in this part of tutorial, we will discuss drawings creation. In the first part, we create the 3D model for this horizontal equipment. Okay, as mentioned on the previous tutorial, we make this vessel with those attachments, and today inshallah we will make a new element to include it to the 3D model. It's not indicated in SEG library, so we will generate it manually and add it to the 3D model, and we will learn how to add it to SEG bill of material to export it to our drawings. At the beginning, we will create those two clips here, and we will use the a new type for the blades here available in SEG. If you select nozzle N2 pipe, which is this nozzle, okay, that nozzle, and from here, from external attachment, we will find a long blade. Okay, so we will select this one and make into support one, sorry, to support one, and from here let's select a longitudinal blade by that way if you would like to make it in external or internal, but in our case it's external blade. You have the ability to make it a channel like that, or UBN internal or external. In our case we will make a long blade. Let's define the height as 50 millimeter. The thickness, let's make it 8 millimeters. The material, let's keep it as it is, and for the location, let's make the location equals 1500. The orientation, let's make it at 0, and the width, we will make it looks like the height, which is 50 millimeters, and we will have two blades around the pipe. We have two long blades here, so we will make one of them and better it by SEG. So let's close, save, and from here let's create the 3D model. Okay, now as you can see here, that's the clips, and we may need to rotate it 90 degrees. Okay, after that we will make a modification by adding a hose to this clip. So from here we will change the orientation to 90 degree, and let's increase the location a little bit, and from here click save. Let's add another clips to nozzle N9. So from here we'll select elements and external attachment and long blade, and N9 support one. Okay, and from here let's keep all information as this is, and from here let's select looks like N2 support to avoid repeating the information again, and from here let's click start the assembly to modify the first clips and creating the other clips on nozzle N9. Okay, now we have those two clips, and we need to make a hole cut on the first clip. So let's open the first clip from here. That's the first one, and let's create a sketch, and from here let's add a point defined this point vertically to the middle and to the middle of the horizontal. Click finish, and from hole feature, let's select this and define the hole diameter to be, let's say, 14 millimeters, and click save. The same thing we will do it with the second support. So from here, let's open the second clip on nozzle in line, and from here let's add a hole at the middle and make it horizontally and vertically with the mid span of the blade, and from holes define it as 14 millimeters and click save. Now we generate those. The next step, which is creating this part. This part is not included in SVG, and we will make it manually, and we will learn how to create it and add it to the 3D model. Okay, from here let's create a new part, and from here let's create a sketch, and let's define the inside diameter of this equipment. So let's check the general arrangement. Here that's the inside diameter, 1981. So 1981, that's the inside diameter, and we have a pipe here with outside diameter. Let's check the 3D model. So it's 2 inches pipe. So if we select this one, so that's the outside diameter of the pipe. So let's define this diameter like that, and from here we will measure that from the drawing. But right now we have this clip with 50 millimeters, the two sides, 50 millimeters and 50 millimeters. Okay, and we have a hole here at the center with 14 millimeters, and let's make it horizontally with that one and vertical with that one, the center. So we have this point referred to the center span of the line. Now let's convert all of those lines to construction lines, and from here we need to measure the actual location of this one. So let's create a quick drawing to check the dimension, and from here let's add that view with the scale 1 to 50, for example, and let's take a section. So from here let's take a section before this nozzle, and let's measure the distance from here to the inside diameter of the vessel. So it's 350.5. So from here let's add a point at the center. So from here to there, $135.5. So that's the location of this clip. Now let's draw the required clip, this one, with those dimensions. Okay, so from here let's make that sketch, check that one. Okay, and again we have another line with 50 millimeters, so we have that one, that, and convert that one to construction line like that. Now we need to define the those lenses, 76 and 70. So that value is 76 and 70. Okay, and for that one it's 41. So here it's 41. One more thing, we need to add an arc here. So you can do it by using that one, which is arc like that. Okay, and now let's finish the sketch and make extrude to this element. So let's make an extrude with 8 millimeters, And from here, let's convert the material to steel. And the color, let's make it yellow, smooth yellow. Okay, now we have this part. If we make this sketch visible, we can make a rotate or pattern, circular pattern for this part around the y-axis. So from here, let's select this pattern and make two plates from that one around the y-axis. And let's save this part. Now, if you try to save it from Autodesk Inventor by clicking on save, you will not be able to save. So for saving, you should open SVG software and from here select save document, save active document, and you will receive this form. So from here, let's create a new project, external parts. So we will generate a new folder called external parts and add this part, which is in 2 and in 9 supports. Now let's add this part to the 3D model. So from here, let's import this part. So from external parts, let's add those two items. And from here, we can make some constraints for that one. So from here we have, the first one for N2. We have the axis, which is y-axis. So we will make it with that one. And from here, let's select that radius to the inside diameter of that one. So we have this support by that way. And if you try to move it little bit like that, okay, so we can remove this constraint now, and from here we can make those parts by that way here fitted to that surface. Okay, so it will be like that, and from here let's make that surface with that one, and we could rotate this plate a little bit back, okay, or make the extrude of this part to outside here. As you can see, we generated on that side, so we could move it a little bit with an offset from the main part. Okay, how we can do that? As you can see, we have this work plane which is at the center of the part. So if we move it, take an instance from it with the half thickness of the blade, so the first blade, and let's move that at the beginning here, and from here let's define this sketch to be located on that plane. Now in that case, you will get the correct configuration like that by moving this clip and make it shifted to the vessel. Now the same thing, we will do it with the next support. So from here, let's make constraint with the center line here, and the same with the vessel center line with that one. And the same thing, we will do it here for that constraint. Now we have this support clips for this nozzle, and if you would like to add a tightening bolt for this one by using SVG library, external library, here from here, if you open the accessories, you will find some accessories here. You can use it for like bolts, nuts, if you would like to add that one. Now we will learn how to add an external item to SVG bill of material. So from here, let's open the bill of material, and from external bill of material, let's select the vessel. That's the first step. After that, let's add the quantity. We have 4 supports. The description is 5 support clip, and for the technical characteristics, it's a plate. Let's say let's measure the dimensions of this plate. So the maximum height. Sorry, let's create a sketch here. So let's make that one visible. And from here, let's measure the maximum width 146. Okay, and 177. Okay, 177, 146, 8 millimeters. Okay, the material is SA. That's the material, and for the weight, let's measure the weight for this part. It's 2.6 because we have two supports. Okay, so it's 2.66, and for the part name, let's take the same name here, part number 1. Demarcus, keep it as it is empty. Okay, now we have, if you check SEG bill of material, you will find the last row here for the pipe support. Okay. Now let's proceed to create our drawings. So let's close this drawing, and we have the complete 3D model for the equipment. Here, as we discussed on the first tutorial part, we generate the 3D model, make the modification for the stiffening ring here, add all pipe supports, add the nameplate, add tightening bolts, and the manway. Now let's proceed with the drawings, and let's take a look how we can do that. From SEG tree, let's select the equipment mode, and from here you will find the design data here. Now we need to modify this design data. You have 3 different ways. The first way here, if you would like to double click on the cell and modify the value directly from here, you can do that. By removing the selected checkbox, this value will not be exported to your drawing. The second way, by importing an Excel sheet. That Excel sheet should be filled by that way. Here, if we open that one, you can figure that you can fill this Excel sheet. You should have 3 columns and no empty cells. You should have a value inside each cell and start directly from A1 up to C1. Okay, now we have those values, and now let's import that Excel sheet here. So from import Excel, we will select the design data file from the desktop, and now SEG will ask us if you would like to empty the grid and fill it again. So we will accept yes. So the previous design data will be removed and we will replace it with that one, and let's click on save. Now let's start creating the drawing. So from here, let's right click on the vessel, and from drawings, let's select create drawing, and from here let's define the drawing size. So let's select A1, and from the active view you can select the required views in your drawing. We will need to make an elevation view like that and make a side view. After that, we could make a key plan. So right now, let's make 2 views. So we have an elevation view and back view, and let's define the spacing between them as 4 centimeters. So all spaces here, if you take a look to that node, all spaces are in centimeters. So that value will be in centimeters. From here, let's take a look to the elevation view, and you can select the orientation of the elevation view. So if you take a look from the left view, so that will be the elevation view. If you take a look from the front view, so that will be the elevation view. So in our case, we need to make that view as elevation view. So from here, let's select left view, define the location of the view in X and Y direction. Let's make the scale 1 to 14, and from here let's add the design data table, bill of material table. And the nozzle table, we need to add a nozzle table, and let's add the notes. If you have more notes, you can add it here. And for the welding detail, let's open the welding detail and select the required welding details. We will need this detail, no elbows, and nozzles without reinforced bad, nozzle with rebad, and we will need this detail, that one, and let's select that detail if required. No. Okay, so let's click on save, and from here let's add the drawing title. So it's general arrangement. Okay, and it's the drawing number. And from here, let's edit the revision table. So from here, it's revision 0, description, issued for review. Okay, and prepared by. Click save. Now let's add some empty rows. Okay, and from the design style, from this tab, you can define the required number of sheets per your drawing. Here you can add up to 3 sheets per drawing. In our case, we have a little bit huge bill of material, so we can export it in a separate drawing or a separate sheet. And we need to add another sheet for the 3D model. So let's check if we can make 3 sheets here, and the size of the second sheet will be A3, and the size of the third sheet will be A3, or let's make it A2. Okay, and from here, let's move the bill of material table to be in design 2. So the first sheet will include the views and the other tables. The second sheet will include the bill of material as we defined here. The third sheet, we will add the 3D model with the balloons on it. Or we could make it 2 sheets only, okay, and increase the size of the sheet, of the second sheet. And we could add the 3D model with the bill of material with the notification. Now let's click on save and click on create drawing to proceed with drawings creation. Here, if you take a look here to this tree, you will find we have 2 sheets, first sheet and that's the second sheet. For the first sheet, we have the views, and we after filling the bill of material, which is on the second sheet, we will open the first sheet to check the views and the other tables. Okay, here that's the first sheet, and now the building details will be generated to the drawing. Okay, now the drawing is done, and we have two sheets. Here's the first sheet, includes the views, the elevation view and the back view, the design data table, the notes table and nozzle table, and we could make a quick modification for the view location and scale. So from here, right click, and from drawings, let's select create drawing, and let's modify the location of the view a little bit and increase the scale and increase the spacing a little bit, and click generate drawing. Okay, now we will make a modification on the second sheet, which is modifying the bill of material location. We will make it start from here. So let's make arrange this one. So from table layout, let's make the arrangement start from top to bottom like that, and the direction from top to bottom by that way. And let's click on save. So now you can figure that the bill of material arrangement will start from top to bottom. So let's move the bill of material here. Okay, now that's the bill of material. So you can increase the width of the cells by, if you right click on that and increase the width of the cell, and on the same thing we can do it from here, increasing the width, and you can make sorry, modify the alignment of the text inside the row by that way. So let's modify the alignment and click on save. Okay, now we have this bill of material, a complete bill of material for your equipment, and let's add a 3D model view for the equipment here on that view. So let's make it scale 1 to 20. So let's add it like that, and one more step we will do it. Let's remove this title, and from here we need to reflect the balloon item number for the items. For example, if you select the balloons, and from here you will find the different types of balloons. In that case, we will select item number balloon. So if you select this head, for example, and select parts only, like that, you will find this balloon is empty. For the same for the shell, if you select the shell, the other shell, you will find all balloons empty. So how to fill those balloons? From here, let's save this drawing, and let's come back to SEG software, and from here we will select the update item number. This checkbox will give you the ability to reflect this item number to the 3D model on Autodesk Inventor, because SEG make a comparison between the items and select the identical items. Like here in this flange, for example, we have 6 identical items: 4 nozzle N2 flange and N2 flange 2, N9 flange 1, flange 2, flange 3. So SEG compare the description and the technical characteristics of the material and the weight of that item. If they are identical, that means they are symmetric or identical. So SEG will give them the same item number. So to reflect this item number, we will need to update the item number. So from here, click on update item number. This process takes some time because it takes around 3 up to 5 seconds for each element. So we will wait until updating the item number and complete our drawings. Now, after updating the item number for the bill of material, if we come back to the drawings, automatically you can figure that the balance will be filled. For example, here we have item number 1. If we go to the bill of material, item number 1, we have 2 items from this one. It's an ellipsoidal head with inside diameter with that value, nominal thickness, minimum thickness after forming a straight flange, and here that's the material and the weight for both items. So if we select this item and select item number in bill of material, you will get that value. If we select this flange, it's item number 10. This pipe, it's item number 22. So if we check item number 10, here it's a flange with 3 inches. Weld neck rest face with clasp was 150, schedule 160. And item number 22 is a seamless pipe, 3 inches, schedule 160, and that's the length of the pipe. Same if we select this stud bolt, for example, and here if we add a balloon for the nut, so item 66 and 67. So item 66 it's a nut, okay, and 67 is a stud bolt. Okay, so by that way you can reflect the bill of material of the item number of the SAG bill of material to the 3D model and reflect it to your drawings. Here let's come back to our drawing here and let's create dimensions of this equipment by adding the definition of the inside diameter. So from here to there, let's define the inside diameter. So from here, let's edit the text and add. You can see that the value is not be it's a fixed, it's a constraint. You cannot change it if you modify the text. Just we will add a notification that the inside diameter. Okay, and let's add the some the 10 lines here and on the other head. Those are the 10 lines. And let's add the center lines of nozzles to define the location of the nozzles. So from here, that's the first center line, the saddle for those nozzles. That one. It's a nameplate. Nozzle. For the other nozzles, the same thing we will do. The second saddle, that nozzle for the lifting lugs here and there. For those hillside nozzles, let's add center lines, and on the other view, let's add a center line here for the vessel, and let's add center line for those hillside nozzles like that. And now let's add some balance and define the reference line or the datum line. Here you can figure that the datum line is located on the right hand side. So we will define the datum point to be at that line. So from here, from ordinate, we will select the vessel and define the datum line to be at the town line. And now let's add the location of the nozzles for all nozzles like that. So automatically it will appear by that way. The same thing we will do it at the bottom nozzles. So from here, let's select this one, select the saddles and the second saddle. And for the lifting lugs, we forget to make it. So from here, let's select this one, the first lifting lug, and that's the second lifting lug. Okay, now let's add the balloons, and let's hide the origin point. So from here, let's right click on any dimension and hide the origin point. Let's define the shell lengths. So that's the first shell length, and that's the straight flange. The second course, the third one, and the second straight flange. And we will make a modification here for that one. So let's define straight flange equals like that, and let's copy that modification here. So it's the second straight flange length. Okay, now let's define the tan to tan. So let's measure the value from here to there, and let's add a text, tan to tan. Okay, that value. And let's add the balloons for nozzles. So from here, let's select balloon, and from here select nozzle tag. So, and from here let's select the nozzle balloon. Okay, as you can figure, we select the manhole flange, not the manhole nozzle. So you can attach a balloon like that for the manhole and remove the previous balloon. And for the lifting lug, let's select the lifting lug, and from here select nozzle tag. So it's lifting lug 1 for this nozzle. It's N7, N9. Okay, that's the flange. So by the same way, let's select the nozzle itself and remove that balloon for the flange. Select a balloon for the nozzle tag. Like that. Make it aligned with the next balloon. No problem if you cannot select the nozzle. You can select the flange. After that, define the balloon of the nozzle in a correct way. Like that. Sorry. Make it aligned by clicking on Control during selection. For this nozzle, we will select the nozzle itself, and the same for the other one. Select the nozzle, not the flange, and remove the balloon of the flange. So we have the balloons like that by that way. And here let's add another balloon for that nozzle. So let's select this nozzle, and from nozzle tags, let's add a balloon for this nozzle. So from here, let's select this one. Sorry. Continue. And the same for this nozzle. We could select, sorry. We could select the control during selection to make it aligned and perpendicular to another nozzle. So same thing here. That's the sliding saddle, and here we have the fixed saddle. Okay, and if you would like to add some balloons related, define the item number like that for the main items, like the shell courses and like that. And if you would like to add a notification like the part tag, like this head description, you can add it like that. For the for that the same view, we will add some notification like longitudinal welding line orientation and the datum line. So from here, let's select that view and select click on S, or from here you can select sketch, start sketch. So you can add some lines or text over this view. So from here, let's define the datum line. Okay, that's the datum line. And let's rotate this value counterclockwise. So that's the datum line. And if you would like to add a right hand line, well, like that. Okay, make it, rotate it like that. And take a copy from that one, from here to there. And define it as right hand line, left hand line, like that. Now let's add the seam line orientation. So it's longitudinal seam line 1. Okay, that's the longitudinal seam line 1. So let's take a copy from that one to here, the second longitudinal seam line and the third one. So that's second one, and here the third one. And let's add a circumference seam line 1, and let's rotate it like that. Take a copy, select first, and take a reference point. We have that line, another line here, and the last one. So that's number 2, seam line 2, 3, and the last one, number 4. Okay, now let's click on finish. To define the center of gravity of this one, the accurate center of gravity, you can generate it automatically from here by clicking on the view, and from here select center of gravity. So here that's the center of gravity, and by using the SEG blocks you can add this to define the center of gravity of this equipment in the empty case. Now let's add some other dimensions here on the other view, like the saddle height, the base plate width, and let's move this title down here, the helicide offset of both nozzles, the projection of the nozzle. So from here to there, let's measure to the facing of the flange. The same thing, we will do it with the bottom flanges, the projection for the bottom flanges, and the projection of those nozzles to the center line. So you can add that value like that here, or you could move it a little bit at top here, so that will be the center line from the top, like that. And let's add some balloons here and there. So that's the nozzle tag. Let's select nozzle tag, and let's add that one here and there. The same for the nameplate. Sorry. Okay, and let's add a location for the nameplate here, because we forget to add it. So you can move it down here, and let's add a balloon to the nameplate from the reference timeline. Let's move this title below here, and let's define the location of the saddles and the spacing between them from the tan lines. like that. And let's add a key plan for that one. So from here, let's select project view, select that view, and let's create key plan. And this key plan, we will change the scale of that one. So let's name it as a key plan. And if you would like to make a modification on the text here, you can do that. But right now, let's change the scale. So let's make it 1 to 40 and break the view to be able to change the location of that one. So we can move it like that. So here it's the plan. So here that's the view, which is the key plan. You can move it up here. Or if you would like to move it outside the drawing, you can do that. And from here, you can define the orientation of the longitudinal building line orientation. So from here, the orientation of the vessel, it's 0 degree, 90 degree, 180, and 270 degrees. And here it's 0 degree. Okay, and click finish. Now if you would like to add some balloons at the top to define the balloons at the top, so you can add that by that way, and by using the attach balloons you could add the other nozzles by that way. And if you would like to add another nozzle, you cannot select. Let's for example try to add N7 here. We cannot select N7 because we have too much lines, so easily to select it you can attach balloon like that. After that, double click and modify 7. By that way you can add a text like that on the balloon tag. And for here, let's make an extend for the center line. And for the balloons, let's select nozzle N4, and let's add attach balloon and as the other nozzle, which is N3. Now we have the general arrangement drawing, which include the revision table, the design data table, and the nozzle table here. Now let's add some welding notifications. The welding notifications here, we have this detail for the circumference welding detail. So let's name it as W1, and here we have W2 for the longitudinal welding line orientation. And now if you would like to modify that, so we can make edit text, so we can modify this value as 4 minus or -1, and for here you can define that value, sorry, 2, and that value is 1. And you can make a copy for that, copy properties, if you would like to define this by that way, like that. The same thing, we will do it with that one. Okay, so you can modify and change the welding tail. Now let's add this balloon and refer it on that drawing. So from here, let's select insert sketchy samples, and from here let's select sample W1 for the circumference welding lines. So we can define the circumference welding lines like that. And for the longitudinal welding lines, let's select W2, so we can define the welding lines, longitudinal welding lines like that. Sorry, let's move that one to here. And for the nozzle to flange, let's add welding line number 3. So it's welding line number 3 for nozzle to pipe. So from here, let's select style 3. Okay, and sorry, for those styles, they are it's building detail 2, so let's modify it like that. Okay, and let's insert W3. So if you would like to modify something like that, you can add the welding style to the nozzle by that way. With the nozzle to shell for nozzles without reinforced bed, it's NW1A. So from here, if you open the nozzle details, NW1A. So for nozzles without reinforced bed, so the weld detail here will be related to that. And for nozzles with reinforced bed, it's NW3A. So from here, NW3A. So we can modify and or edit the weld style. By that way, it depends on your drawing requirements. So if you need to add something like that, you can add it. If you don't need it, so it's up to you. Now we have the general arrangement drawing. We can deal with this general arrangement drawing by exporting it in DXF extension, DWG extension, or PDF. So if you would like to print this drawing in PDF format, so if you right click on the drawing, and from here you can export to, and you will find here a list of extensions you can export to it, like DWF, PDF, all of that. And you can make a save copy as by using this button. So if you click on save copy as and open this form, you will be able to select on some other extensions like a PDF extension. So if we select the PDF extension and make it VA, for example, and save copy as from this drawing as PDF. Okay, now after exporting, let's check the project here. So we have this PDF. Here we have the two sheets. The first sheet includes the two views of the drawing, including the location of nozzles and the main dimensions of the equipment, including the design data table, the notes table, the nozzle load table. And the second sheet includes the bill of material and the balance, which indicate the item number of in the bill of material. By the same way, you can make other drawings for the, let's say, for the support saddles, for nozzles, for any other attachment. So let's try that. So from here, let's select saddle 1. So let's select the fixed saddle. And from here, let's select right click and create drawing. Let's select the size of the drawing as A2. Define the number of views. We will need 2 views. So for the fixed saddle, let's open the fixed saddle. Here we have the 3D model of this fixed saddle. And by the way, we need to take a look to the saddle from this view, which is the back view. So let's define the spacing, and the elevation view will be the back view. So that view, we will use it as an elevation view in our drawing. So let's select that. And for the scale, let's make it 1:8. Let's add a bill of material to this one. Let's remove the notes and the welding details. From here, it's saddle detail, drawing number. and let's edit this table. It's revision 0. Let's add this one, another empty cells, and it's a one sheet, and let's create the drawing. Here the saddle details and the bill of material of the saddle. Now let's add some notifications or some dimensions to this saddle, like the saddle base plate dimensions and the height of each rib, like that, the spacing from here to there, spacing from here to there. And let's take a section on that view to specify the whole dimensions. So let's add center lines like that and define the offset of this one from here to there. We have 13 millimeters. The offset from here to there. The whole diameter. And if you would like to add a notification here, like for like that. On the other view, let's add some other dimensions like that, the wear plate width, the top width of that one. Let's add some balloons. So the as a parts, wear plate and the inside ribs. Let's add the inside diameter, the thickness of the wear plate, the thickness of the base plate, and if you would like to add a 3D for this saddle, you can add it like that, and you can control the color and the scale of this one. Let's increase it a little bit, like 14. Okay, and you could add balloons on it like that. Okay, and let's move this view a little bit by hand like that. And for the second one, if you would like to add the other base plate detail on the same drawing and add another detail for the grounding lug, we can do that on the same drawing, but by hand. So from here, let's insert a view and let's select the second saddle, which is sliding saddle. So from here, let's select the sliding saddle and move it at here and define the scale, the same scale of this one, to 1 to 8, I think. Okay, it's 1 to 8. Okay, and make it aligned with that view, align vertical. And let's take a section here, another section for that view for the sliding saddle. So we can add another view for here and modify that for the sliding saddle. So from here, as a sliding saddle, so So this view will be for the sliding saddle. So let's add some modifications, center lines for that one. So we can modify and as the dimensions like the previous one. And let's make one more thing, like making a detail, section detail. So from here let's select this hole outside here and increase the scale 1 to 3, and let's modify or edit the dimensions. So from here to there, the hole diameter or the solid hole dimensions will be like that. Okay, now let's add the grounding lug detail. So from here, from views, let's select the grounding lug. So let's open the parts, and from here let's select the grounding lug. So let's select it from here, and now you can change the orientation of the view, the scale of the view, 1, 2, move it here and make it as grounding lug here as the dimensions for the grounding lug. Sorry, that's the center line. From here, let's define this value to be like that. The same offset from here to there, the whole diameter and the fillet. Now you have this item. If you would like to add a balloon to this one, so it will be item 48, and for this base plate, if you select parts legacy, it will be item 41. So if we come back to our general arrangement here and open the second detail 41, it's a base plate, so that's the definition or description of this base plate. If you would like to add a tag number for that one, like description for this plate, you can do it like that, or for that rib you can add a description like that for plates which identify the length and width of the plates. Here, for example, if you would like to check that, so that's the length of the rib and that's the width of the rib with the thickness. So let's add the thicknesses here, 13 millimeters, 13 millimeters. So as you can see, we generate the 3D model in the previous tutorial, and we make some details by hand, like the internal supports here for the nozzle. After adding the make some other modifications for the ring. On the previous video we made the cut on the rings by hand. So after creating the 3D model, we proceed with generating the fabrication drawings of this equipment, and we did the following, which is creating the general arrangement drawing in 2 sheets. The first sheet includes the views and some other tables like design table, notes table, and nozzle table. We add some dimensions to the general arrangement drawing. We select the welding details, add a key plan, and on the second sheet we generate the bill of material and generate a 3D model, add some balance to this 3D model. Let's add some other balance, like for the lifting lug, let's attach another balloon for the lifting lug clip, and for here let's add a balloon for this nozzle, and let's select the pipe and the rebad. So that's the pipe and the rebad. Okay, so by that way you can add balloons for items. So it's item 47. So let's add a ring. So here we have those items for the nameplate. Let's select the nameplate here, and the nameplate clips, the nameplate ASME nameplate, and the client nameplate. So you can add balloons by that way. Some other balloons for this nozzle and the stiffening grips, another grip. So we have those grips here. Some other balloons for that nozzle, attach balloon, this balloon, and another balloon. Okay, so item 56 is repeated, so they are with the same dimensions. So item 56, so we have two supports with the same width and thickness. Okay, so by that way we generate the 3D model, the fabrication drawings, and we generate a saddle detail, fixed and sliding saddle with some other details like grounding lug and the 3D model for the saddle. Hope that is this session we cover some of your questions about drawing generation by SEG software and how we can use it. Kindly, if you have more questions, kindly contact us for any further clarification. Have a nice day and see you soon, inshallah. Assalamu alaikum.